What's up guys, Dylan Codes here and welcome to day 23 of Advent of Code 2020 in Python. Wow, only 2 days till Christmas already. That's just crazy. If you like this video, please drop a like down below, leave any comments, and let's go ahead and get into day 23. So let's see, Crab Cups. The small crab challenges us to a game. He's going to mix up some cups and have to predict where they will end up. The cups will be arranged in a circle clockwise. Okay, we're going to do 100 moves. Each move, the crab picks up 3 cups immediately clockwise of the current cup. The crab selects a destination cup. Okay, so let's go ahead and get this started. So I think the way that we're going to solve this, getting our puzzle input here, the way that we are going to solve this is we're going to create a list of cups, but treat the list as a doubly linked list. And basically, if you're not familiar, a doubly linked list is just a bunch of nodes that all have values and all are linked up to each other, and you can just go in a circle. So it's a circular doubly linked list. So basically, once you get to the end, you kind of wrap right around to the beginning. So hopefully that makes sense, but if not, hopefully I'm able to explain it here. So input23.txt as file. File, data is equal to file.read lines. Data is equal to line.strip, if I can type, for line in data, and data is going to be equal to, let's make it int of x for x in data. And if we go ahead and print data, what do we get? I do not think that is correct, and I think we should just do data 0 because right now, okay, there we go. Okay, so let's go ahead and say our cups are equal to data.copy. And now we are just going to go through the games. So for blank in range, I believe they said 100 rounds. Then we want to know, well, first of all, the cur cup is going to be equal to cups 0. And now we're going to find an index. So the index of, we want to find the index of cur cup, because for the first round, of course, we know it's in 0, but as you can see here, the cur cup kind of moves around by round. So we're just going to say x is equal to cups.index cur cup. And then we're going to say cup1 is equal to cups.pop, and at what index are we going to pop? We're going to pop x plus 1. But there's the possibility that that goes outside of the length of our list, since our list itself doesn't wrap around. So then we will mod it by the length of cups. And then we will just repeat this twice through. And the reason being that we do this is because the actual index of cur cup might change as the length of cups change, because remember, pop actually removes an item from cups. So we just want to make sure that it's kind of dynamic each time. And so now, we have our 3 cups, and now we are going to compute our destination cup. So we're going to say if if cur cup is equal to 1, because that's the minimum value of all these cups. Cur cup is equal to 1, then destination The destination value of the cup is going to be equal to 9 because that is the largest value here. It's going to wrap back around. Let's see. Let me pull up the rules for you. So let's see. So destination cup. The cup with a label equal to the current cups minus 1. If this would select one of the cups. Okay, yeah. So destination and then else. Destination is equal to per cup minus 1. But if this would be equal to one of the cups that we picked up, then we need to keep going lower and lower until we're not in one of the cups that we picked up. So we're going to say while destination in cup 1, cup 2, cup 3, if destination, so kind of same thing as before, destination is equal to 9, else destination minus equals 1. And I don't know why I've been having this issue. I've been typing colons after random stuff here. Okay, recently. Okay, so now we have destination. So now that we have our destination, the crab places the cups it picked up so that they're immediately clockwise of the destination cup in the same order that they were picked up. Okay, so now then we can say the crab selects a new current cup which is immediately clockwise of the current cup. Okie dokie. So, well, we can just say for cup in, and we're gonna go backwards. Cup 3, cup 2, cup 1. And the reason why I want to go backwards with this is because, so say for example, that we have that cups is equal to 1, 2, 3. If we want to insert 4, 5, and 6 to the left of here, well, say cup 1, and cup 1 is equal to 4, and cup 2 is equal to 5, and cup 3 equals 6. Well, if I wanted to insert them in the order that we picked up, if I said list.insert 4, then we'd get, okay, 4. But then if we said .insert destination.insert 5, then we'd get like that, and it'd be backwards. So if we go in the reverse order of 3, then 2, then 1, then we'll be in the correct order. So then we can just say for cup in cups, then cups.insert destination and cup. Okay. So now we can, and then we just have to find the, well, let me write some comments here. Let's see, pick up. So pick up 3 cups. Find destination. And insert the 3 cups. And now we are going to find next current cup. Okay. So now if our current cup is 0, then let's see, let's call x is equal to index cups.index cur cup, and now cur cup is going to equal kind of the same logic as before, the cup immediately to the left of it, but in case that brings us outside the length of cups, just mod it and that'll wrap us right back around to the beginning. And so that's the index for cur cup. So I'm going to say x because that's the index. And then cur cup is equal to cups x. Okay, so that should, in theory, oh, one moment. Whew, sorry, had to sneeze there. So then that, in theory, should do it. And so now what do they want at the end? What are the labels on the cups after 1? Okay, so we have all the cups here. and they want the labels on the cups after 1. So that'd be like 926 58374. Okay, so now we can just say final is equal to a string and for num in cups, final plus equals string num. Okay, and then final is going to equal to final. Well, let's see here. We'll just say x is equal to final dot index 1. And then final is equal to, we want, first we'll take everything after the 1 on the right side of the 1. So final index x plus 1 onward, and then plus, and then everything to the left of the 1, because we don't want to actually include 1 in the answer. So then we will do final up to x. I think that'll give us the answer. And then if we print final and make sure we did it for enough rounds. Okay, 100 rounds. Fingers crossed. Alrighty guys, so I think I found something weird here with this insert. After doing some debugging, it looks like there's an issue if the index here is for the last item in the list. So you can see over here, for example, the destination is 7, and then the next few items get appended after 7. But so it seems like there's an issue when you try and insert stuff to the right of the last item in the list. So I think what I'm going to try and do to fix this, see if it works here, is, well, let's go ahead and tab that over, and we're going to say if x is equal to if x is equal to, and I don't know if I mentioned this before I started debugging, but also destination, we just found a cup label, and now x is the actual index of that cup label. I don't know if I mentioned that before debugging. So if x is equal to length of cups minus 1, so if this index is actually at the end of the list, as you can see it is here, after round 2, then we're going to say for cup, and this time we'll go in order, cup 1, cup 2, cup 3, cups.append, cup. Okay, so hopefully this will work. Okay, and after some more debugging, I found two kind of big errors. One is we only want to either append the cups or insert the cups. We don't want to do both. So that should have an else right there. And then the second one is we calculated the index at which to insert, but we didn't actually change that to the index. So we're going to say x plus 1 here, and that should insert them to the right of our number in the correct place. And so now if we go ahead and run with our input, what do we get? Go ahead and test that here. Okay, and there we go. There's the answer for part 1. So let's go ahead and see what's in part 2. Due to what you can only assume is a mistranslation, you're not exactly fluent in crab after all. You are quite surprised when the crab starts arranging many cups in a circle, 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered increasing. Oh my goodness. Okay. So it looks like we're not going to be able to use our list method because, yeah, we're going to do 10 million moves. So our list is going to be like way too slow. So I guess, so after 10 million moves, what are the labels on the cups just after 1 multiplied together? Okay, so I think we're going to have to write an actual linked list, an actual circular linked list. Okay, so part 2. This should be fun. So the most basic part to any linked list is the node. In fact, almost to any data structure is the node. So let's go ahead and write a node class. And in the constructor, we just need to say, give it a value and a prev, which is by default none, and a next, which is also by default none, and that should be equals none. Okay, and then we'll just say self.val is equal to val, self.prev is equal to prev, and self.next is equal to next. So basically, we're going to have a bunch of nodes, and they're going to be connected to each other because a current node will have a previous node on one side and a next node on the other side, and those eventually all connect to each other in a circle. This is not exactly the video to go super in depth about how a circular linked list works, but it's going to be very similar to how our list worked in part 1. Okay, I think that's all we need for the node. So now we're going to have a class circular linked list. And we're going to, of course, have a constructor. I don't know what's going to go in for the parameters yet. And we're going to have a method to insert left. And given a previous node, we'll be able to insert it left and a value. So prev node will by default equal none. We'll be able to we need to be able to take the cups out of the linked list. When the crab removes the cups, we'll have pop right. And then we're not going to enter a value, but we will give it a left node. So we're going to pop the node that's right to the right of this left node. And then finally, I think we should be able to find a node. So find a node of a value. And this is also going to return a node. And this will return an int. And find will also return a node. And now, normally, the circular linked list would just be a bunch of nodes together, but for this find method, because we have we're going to have a million nodes. So I think it'll be too slow if we do it the normal way. So I'm wondering if we're able to store things in like a dictionary, because that has constant runtime. I guess let's just go ahead and try it. So we have, let's say self.nodes. Because normally this would be like a head node or a marker node, but that doesn't even really work for a linked list, a circular linked list, because where do you define the head? You know, it's kind of hard to define where the head of a circular linked list is because it's all just a circle. So we're just going to say, we're going to call that equal to a dictionary. And now to insert a node, we're going to have new node is going to be equal to node value. And then if prev node is none, so this is the first node in the list, then we can say new node dot next is equal to new node dot prev is equal to new node. And I think that's it for that. So basically, if it's the first node in the list, hook it up to itself. Otherwise, new node dot prev will equal to prev node. New node dot next is equal to prev node dot next. And then prev node dot next is equal to new node. Well, I think we want to do new node dot prev dot next. So new node dot prev accesses this prev node, and then set the prev node's next is going to be equal to new node, and then new node dot next. So now the node that's after new node, set its previous node to new node, and then we can return new node. But first we want to add self.nodes value is going to be equal to new node, and then also return the new node. And by returning this new node, then we'll be able to set a new prev node, so we can just keep going around in a circle. Okay, so I think that'll look good. And then for popping a node, so we're gonna have this left node. Oh goodness. Okay, so we're gonna say pop node. So this is the node that we're gonna get rid of. Is going to be equal to left node dot next. And the reason why we need to store this node here is because we're getting rid of it in a list, and if we don't, we're gonna need to like manually delete it. Because if we don't manually delete it, it's not going to get collected by the garbage collector that Python has. And because we're going to be doing 10 million iterations, my worry is that we will actually run out of memory at some point if we never delete anything. So we're going to delete stuff. And then we'll say pop val is equal to pop node.val. Okay. And then, you know, normally you would want to handle the case where you remove the last node in the list, but we're never going to have to deal with that in this problem because we're only removing 3 at a time. And if we remove 3 out of a million, we're still going to have almost a million left. So, so let's go ahead and say, well, we just need to remove the connection. So left node dot next is going to be equal to pop node dot next. And then pop node dot next dot prev is going to be equal to left node. And then we're going to delete pop node because we've basically made a we've made a copy of the left node dot next. So delete pop node. And now we want to delete pop node's entry from our dictionary. So now we are also going to say delete self.nodes value. So we want to delete that node that's stored in the dictionary. And then return pop val. Okay, so I think that should work. And then find will simply return. I think this should work because normally if we didn't have them in a dictionary, you would have to circle through all of the nodes until it found one, which could take a long time, especially because you have to make a bunch of different connections and whatnot with the next and the prevs. But if we keep them in the dictionary, it'll just be constant runtime. So return the self.nodes val. And of course, put self in there. Okie dokie. So hopefully that's good enough for us. And then for good measure, just in case we want to like, well, we don't want to print out a million things. I was going to say we could have a way to print stuff, but I'll only do that if we need to debug. Okay, so there's our circular linked list class. And now cups is going to be equal to circular linked list. And at the beginning, prev node will equal to 0, or not C++. It'll equal to none because we haven't entered anything yet. And then, so first let's go ahead and add our stuff from input 3. So, and then for x in data, cups dot insert left x. And I guess I will write a print def get list real quick because so this will return a list. So nums is equal to blank list, and we want to give it a number to start from. So self, and then so we can give it a list, a number to start printing from, and then val, I guess, marker node is going to be equal to self.nodes marker, and nums.append marker node dot val, and then marker node is equal to marker node dot next, and we'll say while marker node dot val not equal to marker nums.append marker node, and this works because each number only appears once in the list. If that wasn't the case, then this would be a little trickier, but nums.append and then marker node equals marker node dot next. At the end, return nums. So now if we insert all this stuff and we print cups.getList, hopefully we see that we print the correct list, and we don't. So what's going on here? I think what we need to do is, oh yeah, so prevnode, we need to update prevnode and then pass in prevnode to insert here. So that way we go around in the list. And of course we want to append marker node.val. Okay, so now you can see, so our puzzle input starting from 1, well, if we can go ahead and start it from 4. 4, 5, okay, so that worked pretty nicely. So I'm going to assume it'll work when we also add the rest of the numbers. So then we'll say for x in range, max of data, so the largest value that we've added, plus 1, and then all the way up to 1,000,000. And we technically want 1,000,001 because we want to include the value 1,000,000. Prev node is equal to cups.insert, insert left x and prev node. So this prev node will just continue on from where it ended up here at the end. Okay, so that, and I'm not going to print that because that would print 1,000,000 items and that's too long. So, okay, so now let's go ahead and say that curcup is equal to cups.find data 0. So the first cup basically from before, it's going to be the same. And then for I in range $10,000,000, this one should be simpler. So let's see, let's pick up 3 cups. Cup 1 is equal to cups dot pop right, and what's wrong with this? Okay, cups dot pop right of curcup cup, and then cup 2 is equal to cups dot pop right curcup, and this will remove things in the correct order. Because it'll always just take the one immediately to the right of curcup, and once the first one is removed, then the next one will scoot right next to it. So that'll work. Okay, now find destination. So the destination will be determined the same way as before. So what we need to do is say destination is equal to, well, if curcup.val is equal to 1, destination, we'll just call it X for our next destination label, is 1, 2, 3, 4, 5, 6. Okay. Else X is equal to curcup.val minus 1. And then while, and so now these are ints, so these are just labels of cups. So while X in cup 1 looks a little familiar, cup 3, if X is equal to 1, X is equal to 1 million, else X minus equals 1. Okay, and now insert the cups. So now we want the actual destination cup is going to be equal to cups.find X. Okay, yeah, so cups.find X. And then to insert things in the same order as before, we can just say for cup in, remember, reverse order again, because our insert function kind of works the exact same way as the list function. Cups dot insert left cup and destination cup. Now the other way that we could do this is if we wanted to put cup 1, then cup 2, then cup 3, then we would just update the destination cup each time with the return value. And then move to update current cup. Curcup is equal to curcup dot next. So that'll run 10 million times, which I don't know if this is the fastest solution. It'll probably take some time, but I guess what we can do here is if I mod, what's a good number? 10,000 is equal to 0, print. Alright, so we can kind of see as we go here. And then destination cup is also a node, so I'm going to delete, it's a copy of a node. So let's go ahead and delete destination cup just to be safe. And so now at the end, we'll have our circular linked list, and then we'll say cup1 is equal to cups.find 1. And total is equal to cup1.next.val, because it wants the cup immediately clockwise and the cup after that. And then multiply those values together, cup.next.next.val and cup1, and then print total. So let's go ahead and let that run. Fix the syntax errors. Now let's go ahead and let that run. And you can see that we are going to slowly make our way up, so I'll catch up with you when it's done. Alrighty guys, and we're back. We've got an answer. Admittedly, that did take like 20 seconds or so, but we slowly made our way there, so this solution kind of sucks, but you know, maybe there's a faster way. I don't know it, but if we try our answer, then that's the correct answer. So if you found this video helpful, please drop a like down below. Remember, my code is available on GitHub, link in the description, and I'll see you tomorrow for day 24.